Um, I would like to thank Nikhil. We have been partnered for almost 4 years, and we have given very good courses, mostly creative kind of things that we have done. And without delaying, let us start today's session. So this is already this is the kind of some similarity that we have done in last year. Well testing. This is the course that we already done last year. Already he has informed to you. So with some more additions and modifications with the requirements of these days uh, problems and challenges. So we designed again and we started this course with that. So let us hope it will have good insights that will help everyone. So all together we can grow. Thank you very much. So today we are going to start our first day of this free workshop well testing. And today, as per the schedule, we will be discussing the introduction part of it, and then what are the types of well testing. Of course, we may not cover everything, so whatever is possible in this time that we will be doing, and the kind of data analysis that we go through. So since we are integrating this technology with Excel, so knowledge of Excel is very important for well testing and reservoir engineering also. So data analysis is the one which is the most key prominent area where oil and gas industry is currently focusing on, where there is no need for investing more for operations. Rather, we can depend on effective data analysis techniques. Like more and more, if you could able to learn this section like of technology, data analysis and quality assessment with different tools. Excel is one among that, and mostly used technique is Excel. So whatever softwares that they include in data analysis, everything has its own significance. But currently, from the past literature and years, we are coming through Excel. Like all the datas, whatever literature you are seeing, and the diagrams, all the graphs that were generated through Excel. So they were already encrypted in the books through Excel. So with that, so many things are happening in future. So basically we have to understand the significance of Excel and how it is going to impact the kind of scenarios that it is going to provide. So that is one thing we have to do. And one technique of well testing that we're going to discuss is PTA, pressure transient analysis. So practically we will try to adhere that in today's session. And then we start our session with introducing our prominent tool, that is MS Excel. And let us see what best we can do with this, with well testing as well as Excel. So introducing well testing. So we need to know few important parameters like when we do this technique well testing, we are going to estimate certain important parameters in reservoir. So we will not define what exactly is reservoir, since well testing is bit advanced to reservoir engineering. So you need to have some basic knowledge on certain things before coming into this course. So why? Because we are not going to start with the definitions of porosity, nothing like that. So permeability means we go directly and start assessing that parameter. And the ranges of permeability, units, millidarcy, darcy, all these things are the prerequisites. So apart from that, radius of investigation. So this is the first parameter we are going to talk about today. So what actually is radius of investigation? So imagine like when you drilled a well, then the well depth will be reached to your target, where exactly crude oil is present. Once you open the perforations, what would happen? There could be some disturbance that might create nearby the perforations. You can simulate that like throwing a stone in a pond, where the ripples will be generated at the place where the stone is touching on the pond. From that ripple, once it generates, it will start moving ahead of the pond. In the same way here, pressure disturbance will be generated near the wellbore. From that point onwards, let us take like a center of a cylinder, like whole reservoir is like a cylinder and you exactly drilled a well onto the center of it. Then you open the perforations. So ripples of pressure disturbance have generated near to the openings, and from that point onwards, it will start moving, progressing into the reservoir. Actually, it will not go totally into reservoir, but it will go towards drainage boundary. Why? Because every well will be having a limited confined area where it could influence. So that area we name it as drainage area. So one well drainage area is for that well. So other wells drainage area could be different. Altogether, they will be in one reservoir. So this pressure disturbance where it was generated near the well bore will start progressing into the end of drainage boundary. So the limit of that influence is the boundary part of that drainage area. So beyond that, well cannot influence. So the influence part is at the end of drainage boundary. So, but how much time it takes for this pressure disturbance to reach from wellbore to the end of drainage boundary? That time we name it as transient time. So the time taken for the pressure drop, pressure disturbance from the wellbore to the drainage boundary, we name that time as transient time. And imagine transient time might take around 8 hours once after opening the well. But what is radius of investigation for this? Like imagine 8 hours is there for reaching pressure boundary from your wellbore to outer boundary. Here, let us take the time around 2 or 3 hours after opening the well. So the pressure disturbance haven't reached the boundary, but it would have reached some distance away from the wellbore. So that distance towards your perforations is your radius of investigation. It could be 20 feet, 10 feet, 15 feet. It could be of anything. So this is how we are going to estimate radius of investigation. No one can see this directly, only the way by seeing the pressure readings, we could able to estimate that. Why? Because we are going to do this is to estimate the end of influence by this well, means drainage boundaries. You need to estimate where exactly the influence of well have been expanded onto the drainage boundary. Why? Because we need to know, based on that, we have calculations like how much oil a well can be extracted, IPR can be constructed. So for that reason, we are going to estimate drainage boundary region. So we will start with radius of investigation. At transient time period, radius of investigation is your external boundary radius. At transient time period, radius of investigation is equal to external boundary radius. Why? Because during transient period, pressure disturbance might have reached to the boundary. So when you start estimating the distance from boundary to wellbore is the distance that can be measured as radius of external boundary. So this is how we can able to estimate radius of investigation with well testing techniques. Let us try to quantify these values with some case values. Then comes skin effect. Probably this is a very familiar term if you are aware of reservoir engineering. So skin is nothing but the damage generated around your well during workover operations, production. It could be of anything, but your well next to it will be skin. Why? Because the skin is a layer where all the parts of that reservoir rock is being damaged by the workover chemicals that you might have used, drilling fluids. So whatever operations you have done, like cementation techniques also will intrude some part of debris into the reservoir area. So that will create a layer around a well, like it will be a layer, like how the well looks to be surrounded with some feet difference, like, maybe 2 or 3 feet away from the well, circularly, some layer will be generated. So this layer is damaged layer. So we name that as skin zone. We have three types of it, like positive skin, negative skin, and zero skin. Positive means damage is there. Negative means there is an improvement from earlier damage. The zero means there is no damage, neither improvement. It is almost equivalent to your reservoir conditions. So this is how we are going to define skin factor. And permeability. So we already know what is permeability. It is the ability of a rock to bypass a fluid. It could be either oil or water or gas. So it is the kind of ability that a rock possesses to bypass a fluid from larger pore to another larger pore through a capillary tube. So this is a geological term, like larger pores are those pores where the oil will be accumulated inside a reservoir rock. From that pore to another larger pore, there will be connected with one smaller pore that we name it as capillary tube. So oil has to pass through that capillary tube from one larger pore to another larger pore. So the permeability happens inside capillary tube. So all the oils will start to move through smaller pores from larger pore to another larger pore. So this is very important parameter. Why? Because a reservoir rock might be saturated with good amount, but when there is no smaller pores, then production of that could be almost impossible. All here the permeability for production is very important. So so that we will be going through capillary tubes and everything like that. So permeability is very important. Imagine permeability is directly related to capillary tubes, like smaller pores. When there is no smaller pore, permeability will be almost zero. So when there is no permeability, you could not able to expect crude oil that can be passed from one direction towards your production well. Then comes wellbore storage effect. This is also an important uh, area. Why? Because in well testing, we will be seeing this particular area mostly at the initial phase. Why? With this wellbore storage is area is like a kind of damage. How we are going to estimate skin, we are going to estimate wellbore damage effect also. So here what happens is wellbore acts like a tank where it holds some fluids. Generally, before production, we do some operations. So you might have drilled a well, you have set casing, you might have sent some drilling fluids. So these drilling fluids will be reaching to bottom and it will start moving from subsurface to surface through annulus space. So in this annulus space, you have to hold this drilling fluids before opening the perforations. For that, we need this drilling fluids to possess a property called thixotropic property, which will hold all the drill cuttings over there. So once you open the perforations, what happens is because of the pressure difference, like a shock, if it is created near the wellbore, so this pressure difference makes some part of these drilling fluid materials to fall back into the oil, where exactly it will start moving into the wellbore inside the drill pipe. So this kind of material debris, once it mixes with oil, it gives an impression as if oil is coming into the wellbore. How we can able to identify this? Pressure will show you high. At certain time period, you can see abnormal hike in pressure. So this will be adjusted after some time. So this abnormal hike shows that your well have been affected with wellbore damage. So the fluid what is coming inside is not just crystal clear fluid, rather it was mixed with some debris. It could be either through annulus or else from the reservoir rock. So all together it will be converted as wellbore storage. So this part will be included in the crude oil and it will start coming into your well. So you can observe this effect in the pressure transient analysis. So we will be seeing to that. So we have to wait until this pressure abnormal height gets into normal. So we need to know what is normal. So after getting that particular trend, then we have to see how much extent it will be continued. Then after that, what changes will be observed. Okay, this is how we're going to see something with that. So I will quickly go into show you what are the things that we have discussed right now. So let us imagine there is a well. So we have discussed about radius of investigation, skin zone, permeability, and wellbore storage effect. So as you can see, the wellbore is here near the. So this is the place where you're going to open the perforation. So oil will start to come. The one which you are seeing a circle, black color circle, is the pressure disturbance created once the well is open. So this pressure disturbance will start moving forward towards the end of your boundary. So you can see, like, imagine if you want to estimate a radius of investigation exactly at a particular time. So right now you can see the pressure disturbance was created and it is progressing. So at a particular time, what is the radius of investigation? You can see this is the arrow mark that will be an indicator for a particular time period. So imagine if time is increasing, then like this pressure disturbances, it will start creating more and more. Like one ripple was created, it starts moving forward. Then after that, another pressure disturbance will be generated and it will start moving forward. So why we are telling all these things are because the pressure over here is different, and this ripple it will be different, and this one it will be different, and this one it will be different. Here the pressure will be maximum near to your wellbore, the pressure will be minimum. Imagine at a particular time period, if you want to measure the pressure radius of investigation, so like that you can see how much extent it has been moving forward into the wellbore. Based on that, you can estimate radius of investigation. But if you have to estimate reservoir pressure in this drainage boundary, means different color will indicate different pressure. And moreover, the one which is close to boundary will be having highest pressure. One which is close to your wellbore will be having lowest pressure. Then we have discussed about skin factor. Like you can see, this is the wellbore. Next to it, there will be a layer where you can simulate that as the layer which was damaged due to the debris, workover things, right now what we have discussed. So this is the skin factor layer. You can see the permeability graph. When it comes close to your well, it is not that declining, but once it reaches skin zone, it will start drastically reducing. Why? Because it has to bypass all through this debris to reach your wellbore. So because of that, the movement of oil will start to get reduced. Why? Because it will not be crystalline like reservoir rock. Whatever minerals it is having, that will not be the same. It will be mixed with the debris that you might have injected inside the well through workover operation. So those things might object the flow of fluid from reaching to wellbore. So in that way, this is considered to be skin effect. And as we know, we have three kinds of it. One is positive skin, which represents damage, and another one is negative skin that has been like if you have done some kind of fracturing technique or something, so that permeability, if it has increased, then the skin will become negative. So if there is no damage, like if there is no kind of like the flow is almost same, permeability is same, means we can say that skin effect is zero. So this is about skin factor. Then, as I said earlier, permeability. Like you can see, these are all the pores, larger pores. So larger pores are the pores where they might have accumulated, crude oil or water or anything. Like when you're talking about permeability related to water, oil, gas. So larger pores are the pores where they are the accumulators. But the fluid will start to move bypassing all the grains from one larger pore to another larger pore through smaller pores. So there could be number of constrictions over here. So the fluid has to move through the layer and it has to reach to your wellbore. So it has to pass through capillary tubes. So imagine if you are estimating, just a minute, I'm going to show you how the fluid will move. So like blue represents water. So once water starts to come, it will flow towards the wellbore and it will start moving towards the uh, wellbore so that it can be produced through the well. So this is one way of representing the permeability. And the equation, Darcy's law, this is the reservoir. If it is rectangular, so we're going to go with this equation, which is Darcy's law. Q is equal to minus K by mu dou P by dou L. So K represents permeability, Q represents flow rate, A represents cross-sectional area of your reservoir, mu represents viscosity, and dou P is the pressure difference. Why? Because fluid will flow from high pressure to low pressure. So always there should be some pressure difference. Like the pressure, what we have discussed earlier when it is like radius of investigation. So high pressure is at the boundary, low pressure will be near to your wellbore. With that pressure difference, flow will happen. And is the change of length from where exactly it started and where it is being reached. So mu is viscosity. So this is the equation. If you import all the values from the diagram, like 0 to L, 0 is the length near to your wellbore, L is the length which it has been extended. So you are measuring permeability up to that value, L value. So you are putting those two correspondingly, P1 and P2, which are the pressures related to these both dimensions. So after putting that value, you will be getting the value of permeability in this equation. So QL is equal to minus Ka by mu, P2 minus P1. And the measurements for permeability, we take it as millidarcy. But what is millidarcy is 1 darcy is equal to 1000 millidarcy. Mostly we consider millidarcy as the prominent unit for permeability. So this is about permeability. And this is the diagram like from pressure transient analysis to estimate the effects of skin wellbore damage as well as permeability also. So on the left side, you are seeing a graph generated by pressure drawdown test. So we have discussed already these points, abnormal hike. So this happens because of wellbore storage effect. So you can see a straight line which have been passing through all the points. So certain points were falling on the straight line and earlier points have been deviated to top and the last points have been deviated to bottom. So the first one represents by mostly every well will have similar properties like when you are taking pressure drawdown test. So wellbore effect will be observed at the initial phase of your production. So that shows that the pressure points have been thrown towards top when it is compared with the trend. But when it comes how to estimate this, how to like it's a diagram, we are seeing this as a diagram, but we have to see practically like how this can be understood. So that in that way we can use MS Excel to observe this kind of things, which is very important. Like so first of all, we need to know what are the points that falls actually under your test. So the points which are falling on the straight line is considered for estimating permeability. Why? Because the permeability before and after will not be actual permeability. Why? Because before it is affected with whatever the debris that was falling into the wellbore or else skin zone also. Afterwards, lack of the permeability will be reduced. Why? Because there could be a chance of decline in drive mechanisms. Maybe one drive mechanism could be water, so that may make pressure to maintain at certain extent, but after that the energy drive will get declined. Based on that, even the permeability also gets affected. So that is also actually not your drainage boundary permeability. So the permeability what falls with these points which are in between before wellbore storage, sorry, after wellbore storage and before drive declination of drive mechanism, that permeability is actual permeability. So we are supposed to find out permeability by using that points which fall in between wellbore storage effect and declination of energy drive. So this is one thing. And second thing is on the right side, we have the same pressure drawdown only with pressure derivative graph. So what is the purpose of derivative analysis? So this will also tells you up to what time extent the wellbore storage have been impacted. Here, the pressure have been thrown to top. So this is how we are going to indicate. But here, there will be a hump. So pressure drop can be observed as a hump. So this hump will tell you the time limits of wellbore storage. From this time to this time, the production is being affected by wellbore storage. Beyond that, we have some more indications, like if there is any fracture or dual porosity or any kind of pseudo steady state flow effect and all that, that can be observed through uh, pressure derivative analysis. So that also we will be observing. So as I said earlier, the first time period is wellbore storage time period, and between transient flow period. I already told you what is transient time. So time taken for pressure drop from the start of your wellbore to reach the outer boundary layer. So after reaching boundary layer, you will be seeing the effect of that by the pressure which will start to fall down. So that is your pseudo steady state flow effect. So where the energy drive of water will be reduced so that the production also will start to get decline and pressure will be slowly declining. So that is the effect of it. Then if you have to see what are the pressure transient analysis that we have, is drawdown test and build-up test are the most common tests that we will be conducting. So we will be seeing what is drawdown and build-up. Interference test is the test where two drainage boundaries, if they are interfered, like drainage boundaries will be having a boundary if it was not influenced by another drainage boundary. But sometimes two drainage boundaries will be interfered. So in that way, you can use one well to influence another well. For that, we need to know what is the why, because permeability will change, flow rate will change, everything will be changed once two drainage boundaries were influenced. So in that way, we are going to estimate those parameters. Why? Because everything will change. It will not be the same like earlier. So that permeability could be increased because of one another drainage boundary at other time. So that test we will be conducting in interference test and fall off test. So this is also one pressure transient test which will be helping you to estimate, uh, you know, uh, reservoir parameters related to that. So we are not going to discuss about interference and injection follow-up test in today's session, but we are going to see some part of pressure drawdown and build-up in pressure transient analysis. So other tests we will be conducting, we will be seeing in other sessions. So pressure drawdown and build-up, if you observe over here, so initially in pressure drawdown test, the well will be shuttered for some time. Then after that, it will be produced. So the flow rate will be positive. So during shut-in period, pressure will be reaching to maximum pressure. Then when it is producing, the pressure will start to get declined. So opposite will happen towards pressure build-up. So you can see this phase will be continued as initial phase in build-up test. Like initially, you will be producing the well, so you will be having positive flow rate. Then after that, the well will be shuttered. There won't be any flow rate, zero. So parallel, if you see pressure during production, the pressure will be reduced and it will be reaching towards minimum. Then once the shut-in period acquired by build-up, then the pressure will start to rise up. So these are ideal graphs, but generally these graphs will not look as it is. So we will be seeing the changes, like we have to compare this graph with real-time graph with real-time data, and with the changes that we observe, based on that we will be knowing what could have happened in the wellbore. So this is how the graph will be constructed. So we can estimate reservoir permeability with buildup, skin, faults, interference of boundaries, limits of the reservoir. So this is about pressure drawdown test. As you can see, the pressure is being dropped. In real time, it will not look the way how it looks here. Rather, it looks the one which we have discussed. So you can see we will be using these points which were falling on the trend to estimate slope. And with the other reservoir parameters, we're going to estimate the value of permeability, skin, and other things. So this is how we are going to estimate the values of reservoir parameters by the data that we have in real time. So the equation that we use to estimate permeability is Horner's equation. So this is actually diffusivity equation which have been converted to linear form. If that is the case, this is how the equation looks to be. PWF is equal to PI. PW is wellbore pressure. PI is reservoir pressure or initial pressure minus 162.6 Q naught B naught, like capital Q. So capital Q represents flow rate at surface. O is oil. So suffix O, it is for oil. So QO into BO will give you reservoir flow rate. BO means formation volume factor of oil. Mu viscosity, K permeability, H thickness, log K into T. So T represents time, phi porosity, viscosity, CT means total compressibility, RW, wellbore radius, whole square, altogether into a bracket minus 3.23 plus 0.87 into skin factor, that is S. So this is how we can able to estimate the value of PWF, but actually uh, the term here is permeability. But here, what is that we are estimate, like equation shows that we are getting the value of PWF. If you don't know the value of wellbore pressure, then we can use this equation. But how to get the value of permeability? You can see the term permeability over here. But actually, this term is nothing but slope of these points. You can see here, K is equal to minus 162.6 Q naught B naught mu naught by M into H. But here, the same term is there. In place of K, M was written. So what is M? Is the slope of all these points. So that is equal to K. Just take M to LHS side and K to RHS side. Like M is equal to, so this all values you will get. So that means if you have to estimate the value of slope, you need to get all the values including permeability. If not, if you want to estimate permeability, then you need to know all these values with slope. So if you know the slope of these points which are falling on the trend, then we can estimate the value of permeability. So once you estimated permeability, you can get the value of skin factor. So S is equal to 1.151 initial pressure minus pressure at 1 hour. So this is an important pressure point. Why? Because as per API, the skin factor, like the effect of damage through skin may last up to 1 hour. So that is the reason they are specifically mentioning pressure at 1 hour by slope, the same slope that you have estimated from the graph, but it was given in modulus. That means slope might be negative, but you are supposed to take it as positive. Its absolute value has to be taken minus logarithmic of K. Since you already calculated permeability earlier, so you can use that value to estimate skin factor, and remaining things are common with the earlier formula. Then the one which we have started in this session is radius of investigation. So that is equal to RINV is equal to 0.0325 root over K into time. So permeability you estimated. Time you need to specify. Why? Because when time changes, radius of investigation also will change by 5 mu c. So let us go with a case study like estimate permeability, skin factor, radius of investigation at 20 hours by pressure drawdown test. And the data was already given. Since I cannot import full pressure data from the Excel into presentation, space is limited. So I have given initial data. So time in hours, pressure was given. So you can see the pressure is declining. 44123812. So you can see, first of all, we need to know when you see this data, whether it is build-up test, drawdown test, or random pressures were given or whatever. First of all, we need to get that idea, the trend we have to follow it up. So the pressure is been reducing that we can observe here, and thickness of the reservoir 130 feet, porosity 0.2 means 20% porosity, viscosity of it is not 0.2 percentage, it is 20 percentage. So the value is 0.2, may not be this percentage, may not be there. The value is 0.2. Viscosity of oil, viscosity of crude 3.93 centipoise, wellbore radius 0.25 feet, flow rate of oil 348 stock tank barrel per day, and formation volume factor 1.14 barrels per STB. Total compressibility value was given point, I think 00000874 PSI inverse, and pressure at 1 hour 3670. Why? Because exactly the value of pressure at 1 hour was not given in this table, but we can find out in Excel. or else if you have directly the value of pressure, you can use that value also. Why? Because this value will be used to estimate skin factor. So let me take to Excel, and we will try to do this problem. If you have Excel with you, you can just open over there. So the values that you have seen, I kept here. So two things I have additionally kept, like a root T and dou P. So forget about that. Currently we don't have anything to do with these two, but time in hours and pressure. So these two, that is the one which we have seen in the presentation, and remaining all the values I kept here. So H thickness, porosity point to RW wellbore radius, flow rate of oil, formation volume factor, viscosity, total compressibility. You can see the value of total compressibility. It may look like this. So anyway, and initial pressure, the little change is there, 3670. Why? Because when I was estimating, I got a little different value. But anyway, I will show you how to estimate this value. Then the value of M, with earlier data, I got it, but anyway, I will repeat it once again so that you will be getting how to get the values. So three parameters we are going to estimate. One is permeability. So we are going to use this equation, and we need to get the value of M to get the value of permeability. With that, we will be estimating skin factor, and then we will be estimating radius of investigation, but the time was given as 20 hours. 20 hours. So this is the one which we are supposed to keep it in mind. And let us start. I'm going to zoom the values. So time value, pressure values were given. So let me just select these two values. And you can see I already kept the graph over here. So this is the pressure drawdown graph. If you observe carefully here, y-axis is wellbore pressure, x-axis is flow time, and x-axis is in logarithmic. You can see the values were in logs, but on y-axis, the values were in linear. So let us do the same over here. So I'm selecting both. Always x-axis should be on the left side. So time is my x-axis, PWSF is my y-axis. I selected all the values from top to bottom. I will go to insert, and I'm going to use scatter values. And this is the graph. I got it as currently, this is the graph that we got it. So this is my pressure drawdown. I will simply name the value here as PDD. And then I will adjust few things here. I'm going to remove all the grid lines. We don't have much to see with this grid lines currently. So yes, axis titles, one is PWF, and the x-axis one is actually log T, but here it is linear. So let us try to change this value, log T value. So I will go to format axis, go down, you will be having axis options here. So click on logarithmic values. So it will be asking you whether you have to go for it. Just click on OK. So you can see how the trend of your graph have immediately, change. Like you can increase a bit, change the pattern so it will be clear, um, and remove grid lines. And since we have got the value of pressure at 1 hour, which is important to estimate the value of skin factor to be 3625, that I have done it earlier. So let me just verify that whether the value is same. So how to verify that? So these are the points if you observe carefully. So this is the actual axis at 1 hour. You can see the time like 0.1 hour, 1 hour, 10 hours, 100 hours, and 1000 hours. As per the data, it was adjusted. So axis was there near to 1 hour. So this is a good thing. Why? Because we can able to estimate, the value of P at 1 hour by this. So for that, what I will do is we need to understand we need a straight line that should fit in the graph where all the points will fall on that. That points alone will be considered for estimating the values. Okay, go for insert, go for shapes, and just select a line. Actually, Excel has having this function which serves like a scale. So just drag in any direction, you just drag it. But you can see this, you can adjust the slope value of this so that all the points will fall on that. So just try to just adjust it like this. So you can just move, just change the slope. Like a scale, you just change, you can move it, you can just change it, but it will give you exactly, this could be the position where all the points will fall on it. Just I will increase like this. Okay, so both are in blue color. It may not give you right representation, so I will change the color. So if not, I can even increase the tone of the scale also little bit. So you can see the points which are falling on the scale cannot be seen. So what I will do is this could be a position where maximum points are fitting on the scale. So you can consider this as my final position and extend the scale to meet your axis. So this is the point where it is intercepting, could be the point of pressure at 1 hour. You can see 1 hour is here. It is touching on pressure 63650, and it is in between 3700. So you can take the value of 2010 like 3660. I will be taking the value as not 3625, rather I will be taking 3660. So in with this data, I got pressure at 1 hour that is equivalent to 3660. Okay, this part is good for us, but right now we don't need this axis near here. Why? Because we already calculated 1 hour. So just click on the axis, double click it, you will be getting this option, go down, go to labels, and just click on the options, go to low. So it will reach towards end. Why? Because we don't need it. We don't need, points nearby. So only the thing right now we need to see how many points are falling on the scale and what are the points identified. So you can see these are the points from 1, 2, 3, 4, maybe fifth point. 1, 2, 3, 4, 5 points have been deviated from the scale. That means these points could give an indication that your production have been affected by well bore storage or skin effect. But we don't know whether it is skin effect or well bore, but it was affected with damage. So the damage part is there until you reach to this point. So correspondingly, if you start putting time scale, it may come around 7 or 8 hours. So until that, the damage is there. But what about the time for skin? That is up to 1 hour. But well-bore effect might extend beyond skin. That may reach up to 8 hours. You can see if you project it down, you may reach around 6 or 7 hours or even 8 hours. Could be 7 or 8. So that much is the time where your well-bore have been affected with damage. Then after that, the points started to fall on. Of course, some outliers are there, but you can, it will not impact much to your calculations. So first 5 points, like 1, 2, 3, 4, 5, you have to ignore while calculating the parameters. Then after certain points, you can see 1, 2, 3, 4, 5. Again, 5 points have started to deviate. But probably this could be the place where dry mechanisms will start to get declined. There are more indications, not just about dry mechanisms. Pseudo steady state flow might have been incurred. Why? Because of reduction in dry mechanism will reduce production. Then the production from steady state or transient period will reach to steady, and then it will go to pseudo steady state flow period. So that might be the effect of it, or else it could be by boundary also. So that we have to estimate in later stages, but here we have to consider the points until the points deviated from the scale. So last 5, first 5, avoid, and we need to estimate the slope for these points which were falling on that. So let me start estimating the value of slope. and I will be putting the value of slope here like M. So M, we need all the values, but we don't have permeability. So I'm not going to use this equation, but directly I'm going to use this data to get the value of slope. From getting the value of slope, I will be putting this slope in this equation to get the value of permeability. Why? Because other values are already available. So let me just get the value of slope here. So I will be putting the function SLOPE slope and open parenthesis. Here it is asking y-axis. What is my y-axis? PWF. But we need to ignore first five and last five. So 1, 2, 3, 4, 5. From here onwards, I'm going to go up to last. But there also 1, 2, 3, 4, 5. So this is pseudo study and top one is my wellbore storage, comma. And right now it is asking x-axis. So x-axis is in linear, it is not linear, it is in logarithmic. So you should not use directly the value of this, rather you just type as log, open parenthesis, get the value of first one corresponding to your y-axis, go down and reach to the limit of it. Then you have selected all the values, close both parentheses, and you got the slope value to be -77. You can see the formula here. Slope was mentioned in modulus, means absolute. Let me just keep one more function towards it. ABS represents absolute. Open the bracket, close the bracket. So you will be getting exactly the absolute value of slope. So you have slope right now. Then you can estimate the value of permeability. So K is equal to 162.6 Q naught B naught mu naught by M will come down into H. So let us see what value we can get for permeability. So I will start with a bracket 162.6 into capital QO. So 348 barrels per day into formation volume factor into viscosity of oil 3.93 centipoise. Got it? That's by. So permeability is there. I bring permeability to left hand side. That makes my main objective of the equation, and I will bring my slope value towards right hand side denominator. So that is, I will start with the bracket, slope into thickness. So I have kept all the formulas, then I will equate it. So you have the value of permeability to be 25.2 since the units were in millidarcy. So we have permeability for this data as 25.2 millidarcy. So then let us estimate the value of skin factor. So I think all the values in this equation is already available. So you can estimate that. But we need to understand skin factor is having three dimensions. One is plus, minus, and 0. So if you have plus value, that means there is damage. If you have minus, means there is an improvement. So let us see what value we will get. 1.151 into initial pressure. So Pi represents initial pressure. So we don't have that value here. And here also we don't have that value. You can see the value started at 4412, but it ended at 3429. But actually in the data, nowhere it was mentioned where exactly is initial pressure. If this is the case, then what can we do to actually get this value, initial pressure? So pressure drawdown starts, like pressure drawdown test, you have to understand where it starts. So initially the well will be shutted, and then after sometimes it will be produced. So once it is shutted, what happens to pressure? Pressure will rise until it reaches maximum pressure. what is maximum pressure for pressure drawdown test is equal to your reservoir pressure or initial pressure. So from that pressure onwards, you will open the well, then the pressure will be dropped. So when you are opening the well, the production period starts at a time zero. So when it is time zero, the pressure is equal to your reservoir pressure. So that pressure, we are going to use it as your initial pressure. Where pressure drawdown depth time is zero, that pressure is considered to be reservoir pressure minus pressure at 1 hour. Already that value is available by slope value that is also available. Close the bracket. So this bracket concludes full equation, but we have more terms. So I will use one more bracket minus log permeability. We have estimated by phi represents porosity into viscosity into total compressibility into RW square. That is well-bore radius square. Square means power 2. So close the bracket. One more bracket. So we have closed two. Yes. Similar colors on the edges of the bracket that represents that equation was completed. Plus 3.23. Sorry, 3.23. Close the bracket and let us enter. So you have actually a positive value of uh, you know positive value of skin factor that we already discussed. What is the positive value of skin factor? It was always showing to be 6 or 5.96. So that means the well was considered to be damaged. So there is a damage around your well bore. So that has to be fixed to increase the production. You have to reduce the skin factor towards zero so that the production will be enhanced. Permeability also will be improved. And if you could increase more permeability, the skin factor will go towards negative, so that it will be even more better. So through hydraulic fracturing and other techniques are there that can be used to increase skin factor value. So the damage is there around the well bore. Then let us come to radius of investigation. So let me just for 20 hours. So as I said, it started at well bore. Let us see at 20 hours how much feet it has been moved forward. So that is equal to 0.0325. Square root is there. Cross multiply and you can make it as square SQRT. So you can open the bracket. One more bracket. Permeability into time, which was mentioned to be 20 hours by another bracket. Phi mu Ct. So phi was porosity and to mu was viscosity into total compressibility. Total compressibility. So close it and one more bracket and enter. So 278 feet, the pressure disturbance have progressed into your reservoir. So this is how that radius of investigation can be estimated. So we have estimated permeability, skin factor, and radius of investigation. Permeability was observed to be 25.2 millidarcy, and the skin factor was observed to be 5.96, which is positive, that represents damage, and radius of investigation is 278 feet. That of course, that is like not that much it may have to progress, but based on the data that we got it, but it depends. Like if you have real-time data, you will be getting exact values. So this is about today's session. So I have some questions